for 25 years, have been with FTS for going on 6 years. Thrilled to have this webinar today. We're going to turn it over to you, Charles, or sorry, Tom.
Thanks, Gary. I appreciate it. And thanks, Gary, and thanks to everyone for attending today. We appreciate your time and interest. I'd just like to point out I've been in the industry for 40 years, but I started when I was 10. So I'm really not that old. But I'm sure, given the subject today, that people that are on are particularly interested in flooding issues and probably familiar with some of these statistics. But I just wanted to start off by talking about weather-related fatalities, just real briefly. And in the 30-year period from 1984 to 2013, there were an average of 85 flooding fatalities per year, and that was the leading cause weather-related fatality over that period. There were some years when, in a given year, hurricanes were more, or heat stroke, or things like that, but the average annual over that year was flooding. The Weather Service reports that from 2010 to 2019, the average annual flood fatality went up to 98. And really key to what we're talking about here is 62% of these were vehicle related. So just again, year after year, flooding deaths are at or close to the top of weather related fatalities. So this map here shows. Yeah.
Tom, can I just interrupt for just a moment? So yeah. It sounds to me as though a great number of those fatalities could have been prevented. Is that what you're trying to say?
That I think we'd have to be able to say yes to that. That warning people in advance or actually preventing them from entering dangerous situations. Obviously, if they hadn't driven into the moving water or body of water, I think clearly we'd be saving lives if we could prevent that. So did that answer your question, Gary?
Yes, thank you.
Yeah, and that's what this is all about. I think let's just be clear that what we're talking about here is saving lives. This map here is again from the Weather Service, showing for the 9-year period from 2010 to 2018 the concentration of flood fatalities, and clearly a large concentration there in Texas, where they have a lot of low water crossings, and then up through the Midwest, Arkansas, Missouri, pretty serious there. The only two I notice on here that don't have any are New Hampshire and Massachusetts. So every other state was affected in that period. It's significant to the Weather Service. They probably most of you are familiar with the Turnaround Don't Drown program. It's education. They go into schools. They go to just get the word out through the media. And, a couple key takeaways here are just 12 inches of moving water can carry away most cars, and 2 feet of water can carry away SUVs and trucks. Most people don't realize that. So this whole education.
No, I just fired up while you're talking.
So this whole public outreach and education is critical, and there are quite a few that die from walking into moving water, and some people a mere 6 inches can carry someone away. So obviously, hopefully, everybody on this call knows that it's never safe to drive or walk into floodwaters, and want to help the Weather Service keep getting that word out. So what we're going to be talking about today is warning people. Obviously, the main situations, the main locations that we get contacted about instrumenting are underpasses that in heavy storms can get overwhelmed. Often they'll have pump systems to drain them, but they can easily get overwhelmed. We're getting more and more interest and need in the coastal flooding situation with rising sea levels. And the most common that we've dealt with is low water crossings. And I'll give a definition of that in the slide here. Low water crossings, according to, this is taken from Wikipedia, basically it's providing a bridge when the water flow is low. And basically a location that in high flow situations, their traffic will not be feasible through there. There are different names. There's a ford. A ford is typically wet but passable. There's an unvented ford, which just the water's going over the road. This is a picture of a vented ford where there's capacity for some flow in really low water situations, but once they get over past the the water's over the road and hazardous. And then there's also low water bridges that so the typical way that these situations are dealt with in flooding events are barricades, and that's still the most common thing that road crews, public works, emergency management, they're out putting barricades. Often they're responding when they're notified by the public of a particular location that's gone underwater. In some cases, public works will be out, or the police will be out doing, making the rounds, checking on locations that they know are problem sites. And so this works to a degree. And problems with this, obviously, is there's a delayed reaction or deployment. In a large-scale event, there could be significant delay. If there could be, say, 10 or 15 locations that all have water over the road, dangerous situations, and the road crew, can only be in one place at one time, so they're out deploying these, and so there's a delayed reaction. And also, in some of these locations might not be accessible at all in a situation. They might be blocked off to problem sites, given their flooding in other locations. So let's go on to the next slide here. So back in the 90s, we were, our main business was flood early warning systems, particularly alert systems, which utilizes a National Weather Service developed protocol for hydrologic data. And we started having system operators contact us about adding capabilities to their system. Essentially, they were sitting in the emergency management center or wherever their operation center was, and they knew what was going on, and they're deploying people. But what they wanted was the ability to immediately warn motorists when water over the road was a hazard. They also wanted that data transmitted back into their system, into their central software, so that they could notify emergency management personnel and road crews. So our belief is that if 62% of these flood fatalities occur in vehicles, that advance warning and keeping people out of those situations, out of harm's way, will in fact save lives. So we developed what we call a high water detection system. So it's an automated system that measures water up to and over the road. It warns motorists of flooding conditions on the road through remote flashers and, in this case, gates. And it reports back to central software to inform key personnel. So the benefits of a high water detection system, again, we're providing immediate response to a developing emergency, and motorists are warned immediately that there's danger. It also relieves manpower requirements during flood for other emergency response activities. The people that might be deploying gates are free to be doing other things that are urgent. Emergency management personnel are notified as actions are taken by the system. All of the communications are being monitored and available through the central software. It also reduces the risk to rescue personnel. So if you don't have a vehicle and people out in swift water, the swift water rescue people don't need to be putting themselves in harm's way. So that's certainly a benefit. Barrier gates can provide additional road restrictions. We know that not, sometimes flashing lights might not be sufficient. They might look and say, I think I can get through there, but a barrier gate is going to provide additional ability to stop people from proceeding. In some cases, we simply close the ingress. In some cases, we close the road completely, and that's up to the agency that we're working with to make that decision. We also have an audit trail of the system data and controller actions. So all of the communications and all of the actions that the flashers took, all of the information, the hydrograph, how high did the water get, all of that data is there for an audit trail. And in addition, we can provide a public website for citizens. They can, if somebody's going home from work, they know there's a storm, they can look, and can they take their normal route home, or are roads closed? They need to take an alternative route. So the basic components of a high water detection system are our terminology, we call it a master, is the station that's monitoring the water level and issuing commands. We've got remotes, which are responding to the master's commands, and it's equipped with flashing beacons, signs, and in some cases, gates. And then the central software that's monitoring the system status for situational awareness, and it issues alarms to key personnel. And it can also provide, as we said, a public website if the agency decides. So here's like just real basic how a system works, just graphically. The water level comes up, the master is going to issue a command, triggers on the remote, it responds that it's on, reports to the base station that it's on. The water level drops down below the flood level, and master sends the remote a command. It reports back that it's off, and the base station is updated that the system has been deactivated. So that's just real, essentially, what how a system would operate. So at a master, again, it's measuring water level. We're going to talk a little bit about the sensors in the next slide, and we are able to set thresholds. Every site is going to be different. In some cases, we're measuring water right at road level. It's just a low point in the road. In other cases, there's a culvert, and it might take 3 feet of water to get up to the over the road, and so that's settable for each location. And a master in our—
Hey, Tom.
Yeah, sure.
This is Gary. So can I ask, so these systems can be set up or deployed the way that each individual site may have its own particular needs. So each solution might be different to the individual needs. Is that what we're saying with this?
Sure. Yeah, and there's a variety of things that's going to be individual. Some of the equipment is the same from site to site, but there's certainly every location has its own characteristics. How many remotes are required based on the configuration of roads in the area. A very simple site is a country road where there's just a sign, a remote up the road in each direction. But in other cases, there could be multiple roads coming into that road where you're needing to inform people at different locations. So in this, we can control up to 32 remotes from a given master. I think the most complicated situation or configuration I know of is we've got one that's controlling 9 remotes. So yeah, the custom things would be the threshold for each site. We're ensuring that the electronics are up out of flood level, so that the height that we're installing that, and all of that would be determined in site surveys with the customer. In some cases, there might be an engineering firm involved as well to do site plans, but every site we would go out and determine what's appropriate at that given location. That answer your question, Gary?
Yeah. No, that was great. Thank you.
Yeah. Okay, here what we're looking at is sensors. We're looking at over in the yellow circle here. We've got a site with 2 pressure transducers. You see the conduit running down the concrete apron there, and it's very common that we'll do redundant sensors, and this could be 2 PTs. Some people like a pressure transducer and a float sensor. We can use radar sensors, though radar is really great in a lot of flood warning systems. You might have a bridge or other structure that you can mount to. A lot of these are less conducive, but basically any water level sensor we can use to trigger commands to the remotes. Okay, so a remote is essentially going to respond to the commands of the master. What we do, so we don't just monitor whether the remote got the command, but we then measure and report the beacon current. So we're verifying that it's pulling the current that we would expect when the lights are flashing to affirmatively confirm that the lights are in fact on, that we didn't just tell them to turn on, they are in fact on. As we said, some sites have barrier gates, and typically what we do, we've got a unit in there called a BGO interface, barrier gate operant interface, where we delay the activation. We're going to start the flashing lights first to warn any cars that are approaching prior to dropping the gate. And we often the gates would be.
I'm sorry to interrupt. What is the range for the remote sites from the master site?
Well, we're using VHF radio, which is a very robust communication. It's basically unlimited if you have line of sight communication. Even beyond line of sight, we're able to. I can only think of one situation where we required a repeater to hit a remote, and that was in a situation where the master was down in kind of a straight 300-foot drop down into this canyon, and we had a repeater up on the top that could. In that case, we had some remotes that the road into this canyon was about 10 miles long, so the pre-warning was quite a ways away. But that's the only.
So in that case, it had more to do with the site rather than distance.
Yeah, exactly. But other than that, that's the only time we've ever had an issue with communications between a remote and a master.
I have a question. If you have an existing gauge and you want that gauge, once it gets to a certain elevation, to trigger a flasher, do you have to also buy a new master to put in the place of that gauge? Or can you use an existing gauge that's within the contrail system to cross a threshold and then send the signal to the flasher?
I think I missed the very beginning of your question, but I think the question was, can you use an existing stream gauge to be a master? Is that correct?
Yes, yes.
Yeah. It would need our controller at the master, but it would be easy to install one of our controllers at a master gauging station and use an existing sensor hooked up to it to send the commands, and so that it would require one of our transmitters / controllers that have this communication capability in it. But as far as all the infrastructure, the sensor, that would all be usable. And if you do have Contrail includes the capability, as Charles is going to go into more detail on the software end of things. But if you did have Contrail, that's a standard functionality that Contrail has.
Charles is going to cover that in great detail. That is really a good question. So, hey, Tom, there is one other question here. I was going to put this off a little bit, but I think it fits in right now. It says, "Is the pressure transducer the only means of sensing depth, depth of the water?"
No, we could use float sensors that trigger at a set level. So we usually use dual floats for triggering the on and off position. Also, radar sensor. You could use a bubbler. So virtually any type of water level sensor that's commonly used, we could interface with and use that to trigger the action.
Yeah, that's a good question. That kind of goes back to its sort of site predicated, right? It just depends on the needs of the site. We do a site survey and figure out what works best for each individual site. But the reality is, it's any type of level sensor we could probably make work.
Correct. Yeah. Okay, I think we pretty much addressed remotes. Okay, so as far as the communication, I mentioned that we use the VHF radio. We're using something called the Alert and Alert 2 protocol, and Alert was originally developed by the National Weather Service for hydrologic data. It was originally intended as a one-way transmission. We developed the capability of using it in a two-way method for command and control, and have transferred that. There's now an updated Alert 2, which is a much more robust forward error correction, just a lot of enhancements to the protocol. And VHF, again, it's far more robust than, say, spread spectrum or some other technologies that are out there. The other thing that we use at times is cellular, and typically when we're doing that, we're using it as a gateway to the network to get the data back into the central software. And that would be in a situation, we've got a DOT in Texas where they're covering a really large region, that they've got isolated subsystems here and there, that by installing a cellular gateway within that system that is communicating within the sites, the masters and remotes are using our standard VHF equipment. But by having a cellular gateway at one of the sites, we're able to monitor all of the communication and issue commands from Contrail. So a couple other options we've got here is blank out signs. We've got signs that would, the other pictures were all static signs, typical road signs that we're used to seeing. We have a system that's going in back east right now where they wanted blank out signs that normally you don't see any message, but when they're activated, you do see a message, and there can be multiple messages. So we could trigger message number 1, message number 2, and that would all be defined by our customers' needs. We're also installing pan tilt zoom cameras in a system that will get implemented in May this year. We've done a few before this. We're doing 15 camera sites at gate sites. They want to be able to monitor whether the road is passable before they remotely tell the gates to go back up. And we've also can activate sirens. We've got a system down in Hill Country in Texas on the Guadalupe River where we're activating sirens. So those are some of the options that can fit into a system like this. I'm going to talk about one particular system just real quickly. The largest system that we've done is in Bexar County, Texas, which is the county that San Antonio is in. We started there in 2009 with 10 low water crossings, and we're about to ramp up phase 4, where we're adding cameras at these 15 locations and have begun the conversion of the system to the R2 protocol. So one of the things that they've found to be very effective, none of this means anything if the public doesn't know that it's there, what it means, and they've done a really great job on informing the public. Here's the county judge, a picture of the county judge at a press conference where out at a site, activating the site, and they work closely with the media there to get the word out. They go into schools, they go to public meetings to inform people. The program there is called HALT, and a couple of years ago it won a American Public Works Association, the Texas chapter, awarded it for effectiveness.
Hey, Tom, you mentioned Bexar County, and you mentioned the number of sites that High Sierra Electronics had installed there. How about total sites that High Sierra Electronics has installed throughout?
It would be in the neighborhood of 500, somewhere in the 450 to 500 range. I don't know the exact number. The majority of those, I'd say probably 80% of those are low water crossing type situations. But we've also done, we recently did a network in New Orleans with at 12 underpasses where the road's going under a railroad, and so certainly have done some of those and some coastal flooding as well.
Thank you.
Okay, so again, just a reminder that really what this is about is saving lives, and while it is possible to improve the infrastructure, that the cost in Bexar County, they've got over 300 low water crossings, and the cost of doing infrastructure, road improvements, bridges at all of those would just be astronomical. It also, and there's some that they do, the long-term plan is to improve them, but in the meantime, installing these are potentially saving lives. So, it's a quick and far less costly approach. The director of public works there in Bexar County, Renee Green, said this one project, in my opinion, has had the greatest impact of all the flood control projects. Granted, it doesn't save homes from flooding, but it saves lives. It's a public safety project. And again, I think that's what we're all about, is saving lives where possible. So I don't know if there are any other questions. I certainly encourage you to post your questions. Yeah.
Tom, there's one more question here that's been posted. Let me ask you this before we transition into Charles. It says, well, can transmitter settings such as reporting interval be adjusted from a remote site? And if so, what is required and how does it work?
Great questions. We are just now implementing it. We continue to do enhancements as we the further we get into this, the more we learn and are able to give additional capabilities. And with this camera situation in Bexar County, we've developed the ability to send commands from Contrail to change the reporting. Like standard, you could be taking an image every 15 minutes, and you decide either during an event or just as a standard practice, you want to go to 5 minutes. We now have the ability to send send a command remotely to update that frequency, and there are about 5 other configurations. And now that we've developed this remote configuration to change the settings in our controller, we're going to continue to provide other things that can be remotely controlled.
That's great. Thank you, Tom. That was fantastic. Thank you. That was a great overview. Showing capabilities. Charles, we'll turn the time over to you.
All right. Thank you, Gary, and thank you, Tom. I'm going to be talking today about the software components that Tom showed and walk through what the hardware and actual infrastructure looks like. But we're going to spend the last few minutes of the presentation today going through and showing the benefits of the software, some things to consider when we're looking at software, specifically for these high water detection systems. And then we'll just give a brief overview and demonstration of that Bexar County system that Tom referenced. So as Tom mentioned, these systems operate locally, they operate autonomously. So they will function independent of what's going on throughout the other systems and without any sort of manual control. So when that water level rises, we're going to kick on the flashers and or lower the gates. And all of that is done through local control and is independent of software. However, software is still needed, and Tom kind of alluded to this, but with the situational awareness, understanding what's going on throughout the system. But we also have some other things to consider on why the software is needed. So leading up to an event, we really want to leverage the software to make sure that the system is working correctly, right? These are complicated systems that go in and they're mission critical systems. So, we spend a lot of time talking about how they can directly save lives and they're a public safety asset. So we want to make sure, leverage that software to ensure that the system is working correctly and optimally. And if we do need to troubleshoot some issues, we're able to do that from the software to as we assign somebody to go out, maybe perform maintenance on the site. We can very easily do that, as well as detect trends and data, so we can be ahead of any sort of issues to really ensure that the system is working as optimally as possible. During an event is really when the software part of the system really becomes important. We spend a lot of time talking about situational awareness, but the software gives you that bird's eye view, especially if you're have multiple systems, multiple low water crossings or underpasses or roadways that get flooded. We want to be able to see that very quickly in one spot, whether it's on your computer or if it's happening in the middle of the night, which is, when these things typically seems like always happens on weekends and in the middle of the night, be able to see that from your phone as well too. So getting that bird's eye view so we can, the key personnel can assign assets and move assets around accordingly. We also want to be able to issue commands directly to these systems. So we kind of talked a little bit about this, but we do have two-way control from the software back into these systems. And the reason this is important, and I'll show this in a little bit, but if we can see that the water's rising at a system and it's not quite ready to activate those gates or turn on those beacons, and but we know that it's going to trigger, maybe we want to be proactive and turn those on ahead of time and be ahead of the game and not wait for the water to rise. Or maybe the water is already on the road and we haven't quite hit our threshold. We have the ability to go in, request new readings, as well as override and turn on those remote sites. And then finally, send the data to the partners. And we'll talk about this on the next slide, but we want to be able to send this data out to local partners. So if we have surrounding counties or cities within the agency, well as other departments, right? Maybe we have a road crew that's independent from the public works or flood control district that we want to provide that data, as well as sheriff's offices or swift water rescue personnel, being able for them to see maybe what are some areas within the system that we're having problems, or we might have to move some assets there to move around. And then also we have this great infrastructure for collecting hydrologic data, so sending that data on to the National Weather Service so they can see what the current conditions are across the area, so they can provide additional level of warning to the public by issuing watches and warnings directly to the public.
Hey, Charles.
So after the event, yes, Gary, did you have a question?
Yeah, can I interrupt for just for a minute? So if I have Contrail, but I also have a website for my agency, can I stream that data onto my website for the public to see?
Yeah, so that's a great question. So oftentimes agencies will already have some sort of DOT website or some sort of roadway closure websites. So we do have that ability, and that should be an important part of the discussion with these type of systems coming online, is where do we want to send that data to after we collect it, right? We want to send only good, valid data. We don't want to be sending incorrect data or delayed data. So it needs to be real time, it needs to be validated, and then we can work with the agency to decide if it's going to an existing website that we want to integrate that data into, or if it's a matter of turning on the public website option, but only sharing particular sensors or particular information to the public, and the rest is behind the username and password with certain credentials and privilege levels to see that data.
Awesome. So much like the hardware, Contrail can be customized as well.
Correct. And we'll showcase that here in a little bit on the actual demonstration.
Thank you.
So after an event, we're going to be leveraging the software to document what happened, right? Hopefully our hope is with these systems that we won't have any sort of public safety issues, but oftentimes they do still happen. And so we want to be able to document what was the water level, when exactly did it get above the road, when did it become an issue that a car could possibly get swept off. And then we also want to document when exactly did those beacons or the gate arms close. So if we have any sort of post-event analysis or interviewing, we can go back and very easily, without having to go out to the site sensor that is recording it locally, we can also just very easily from our phone or desktop be able to see and document exactly what happened during an event. And then finally, to kind of bring this full circle back to, leading up to the next event, maintenance support, so being able to document what's out there and provide all the information needed for the maintenance crews to be able to maintain these systems and keep that system up and running as quickly as possible. So some things to consider when we're looking at software, just kind of a summary slide here. The first one might be pretty obvious, but it is something to keep in mind. The software needs to be compatible with the telemetry or the communications that's going out in the field, especially in particular with two-way communications. We want that ability to be able to issue commands, override the site if it's needed, as well as trigger new readings as required throughout the event. Maintenance and network planning. These systems, oftentimes when they go in, more systems are requested in the coming months and years. So we want to be able to ensure that we are planning the system as optimally as possible and making it easy to maintain going forward, because it will require ongoing maintenance of the system. So we want to make sure that the software is able to handle the planning as well as the maintenance of the system. We already talked very briefly about the weather service, but oftentimes it's really easy to include a rain gauge at each one of these sites. So a particular system could have a master and 2 remotes. We could easily have 1 or 2 rain gauges, depending on the density of these systems. So that's just additional rainfall data that we can leverage, as well as the actual water level sensors. We can provide that data to the National Weather Service. If you're doing any sort of real-time modeling, so forecasting going forward, maybe when will it hit the top of the road, we can provide that data as data feeds to our public and private partners, as well as different departments within your agency. Auto tracking of users and settings is really critical for these mission critical systems. So we want to be able to document if someone turned off an alarm or maybe raised the alarming threshold or deleted a data point. We want to be able to track all of those things. So auto tracking is really critical, especially following an event. Hey, how come we didn't get this text message in the middle of the night? Well, it looks like this person deleted it. Let's go ahead and investigate why, and then maybe change some of our privilege levels so someone isn't able to do that in the future. And then finally, cameras, which Tom mentioned, is a great way to both confirm the conditions at the site, so to see maybe when the water is actually receding, and to get confirmation outside of just the gauge data, and then also to detect if any motorists are maybe driving around a gate arm. We want to be able to document that and have proof of exactly when that happened. So with that, I'm going to go ahead and jump in and just do a brief demonstration of the Bexar County system that we have here. And so this is behind a username and password for them. They also have a public-facing website where this data is fed in to provide that community relations aspect and community education. But I'm going to go ahead and jump to a particular site here. So we can see all the sensors that are located, as well as the 2 water level sensors here down at the bottom, that sensor redundancy that Tom was talking about. We can also see a picture of the master site here. It's actually up high, and we provide lots of different configuration options of these master sites, including mounting them up high to prevent vandalism, as well as any sort of flood waters getting in there. So I'm going to go ahead and click on this water level sensor here. We can see a couple things. I'm going to go back in time and pull up an event from October. And again, this is critical to be able to document even as far in as that site has been in service, to keep track of all that data. So when we look at this site, we can see the water's rising up. This green line indicates where the pressure transducer is actually sitting, where that water level sensor is sitting. So we can see it's actually a negative number. The reason for that negative number is we want it to be relative to where the top of the road is, right? We don't want, when you're trying to juggle all of these water level sensors, we don't want to have to remember, okay, this site is actually 4 feet below the road, and this one's 3.5, and this one's 2.1. We're just going to go ahead and document everything relative to the road. So this black line here as 0 is the road. So this is the top of the road. This orange line is the warning threshold level, and then the red is when we will actually activate the remote site. So we can see the water lining up and rising here. We can see it exceeding the warning threshold and then exceeding the actual road. Right on the at 23, 24, and then we can actually see how high did it get for this particular event, and then when did it get back below the road. And then we could couple this data with the site status of the flasher. So here's a flasher just upstream of that site. And again, we talked about where to place these and being part of the site survey. But we can actually graph this water level sensor with this flasher status, and we can see when this water level sensor got right above the road and got above our actual our site activation level here, we could see this value here, 1025, is actually the raw bit that was transmitted to turn on the flashers. So we can see this change in value here corresponds very nicely with when the site would have activated, and then conversely when the flashers turned off, when the site went back below the activation criteria. Just really quickly, that situational awareness is really important. So here's the Bexar County, just the Bexar County gauges. We're not going to have the City of San Antonio gauges overlaid here, but we're able to very quickly see what sites or low water crossings or road areas are clear and which ones do we have to investigate, as well as seeing those water level readings relative to the road elevation. We can quickly go around and see what sites do we have to maybe investigate and dig into more. And then finally, if there is a particular system that we maybe want to issue commands to override, we can do that right within the dashboard here. So we can see if a water level is trending up or down, maybe we want to either turn off or turn on accordingly.
Charles, I have a question for you. I see the dashboards here. Could dashboards also be tailored for each individual needs? Of, the agency may have different needs and want to see different things for their own dashboards, and they're providing them with specific information.
Yeah, great question. So the dashboards is really the area in the software where we can configure the software to meet the exact need of either each individual high water detection system or your overall situational awareness needs. So these are drag and drop. In this particular case, these are drag and drop widgets that we can move around, change the colors, have them turn to orange when the flashers are on, and then turn back to gray when they're off. So this is the part of the software where we can do that exact configuring that you're referencing there to meet really whatever need the agency might have. Okay, and with that, I'll pass it back over to Gary.
Thank you, Charles. That was great. And Tom, just by way of a summary here, as Tom mentioned earlier, 62% of flooding fatalities are vehicle related, with many preventable. I found the information he provided interesting, and how many inches of water it takes to float a car away and so forth. So doing some preventive warning certainly can prevent so many of these types of accidents. The high water detection systems are proven, reliable solutions to save lives, quicker and safer than traditional barricades. Certainly you can get the information immediately based on water level changes, and however you set that up, rather than someone running out there the next morning, putting out a barricade or that night. And far less costly than bridges or rising roadways. Sorry. Charles, any other questions that you see that we should address here quickly?
So it looks like we have only one other question. It says, is there an evaluation procedure so that we can identify local sites for these flooded roadway warning systems? And I'll go ahead and take that, Tom. So each, as we kind of discussed, each area across the country is different and unique, and even within a county, every single flooded roadway area is unique and presents its own challenges. So really the best steps is, I would say, reach out to one of us. We'll have our contact information here at the end. And really a on-premise site survey is the best way to evaluate these. Google Earth is great, but being on site, being able to see where the actual crossing is, or where the roadway has the potential for flooding, and then evaluate maybe where we're putting our remotes. If it needs to be, right next to a driveway to allow motorists to be able to turn around, and to really document all that information, and then design the system to meet your needs. We use standard components within each one of these systems, but they're adapted to meet the challenges of each one of these systems.
I also see another question on here. One of you can retrieve this. Is any of this different in an arid flash flood prone area?
I would say no. I mean, the equipment is all the same. One of the challenges that we've encountered and talked to people about in Arizona, in particularly, is they've got these dry washes that are pretty wide, and that the main channel can migrate. So that presents a particular problem in terms of where do you put the sensor. So other than that, you do have a place where you can measure the water level effectively, and then the equipment would basically be the same. I also see a question whether we're using High Sierra data loggers, and the answer is yes. It's equipment that we've developed, specifically. We've been doing this for 20 years now, continually enhancing the capabilities. One of the things I didn't mention I don't think on masters, at some point we came up with the requirement for what we call dual masters, where you have multiple streams, that a road crossing multiple streams that can flood that road. So we have the ability for multiple masters to control the same group of remotes. And then before they deactivate, we verify that any of the remotes that are commanding those that subnetwork there are all below the threshold before they turn off.
Thank you, Tom. I think we'll take one more question here, just for the sake of time. It says, can National Weather Service flood warning be fed into the system automatically and then trigger from there, like flashers?
I would say if we were doing that, I think what it would probably require is that being done within Contrail. So if Contrail is, because from Contrail we can send commands out to activate flashers. So I'll yield to Charles on that, whether we could in fact trigger off of flood warnings.
Yeah, so just to piggyback on what Tom's saying. So yeah, that information, it has the potential to be ingested within Contrail. We would like to talk to you, Brian, to get a little bit more information about exactly what you're wanting to do, and then we could potentially add that into the software.
I'm going to retrieve one more question. I think this is very relevant. The question is, are any federal agencies using Contrail software? I'm going to let you address that, Charles. The answer is emphatically yes.
Yes. So we have a number of federal agencies that are using Contrail for a wide variety of uses, everywhere from this high water detection system. So dam safety is really a strong component. We've had a large number of federal agencies using Contrail software for a large number for many years now. And then we also have it going all the way down to the city level. So we have multiple states using full statewide level views, all the way down to flood control districts, counties, cities, and small municipalities. So almost over 200 agencies across the country are utilizing Contrail.
Thank you. Thanks, everyone. If we didn't get to your questions, we will look at them and respond to them via email as well. We just want to make sure that if we said it's going to be an hour, that's going to be an hour. Just again, a recap as far as who we are. We're part of Advanced Environmental Monitoring, a family of manufacturers, proven manufacturers. We represent the three of us represent the three brands of FTS, High Sierra Electronics, and One Rain. And then, of course, you can see that there are other brands part of the family of companies as well. If you have any questions or would like to get with us regarding any of the product lines or the things that we've talked about today, here's our contact information. I do want to just make sure that we're clear on this as well. The slides or the presentation is going to be available. We're going to rebroadcast that. So if there were slides that you wanted to see again, they will be posted. Again, we are also going to contact or send out an email and ask for your feedback on the webinar. We would certainly request and suggest that you be honest with us. Our last comment is stay healthy and stay safe. Thank you for joining us.